So we start chapter 4 off reviewing some topics that you guys have already done in the past. Maybe not to the extent that we're going to in these first couple of sections, but it's all stuff that you have seen before. And the idea is reviewing what you've done, and then we're going to take that concept and we're going to apply the same ideas to quadratic formulas and quadratic equations that we've used this year. So the first thing that we're going to review is isolating a variable, which just means getting it by itself. So on this first example, it wants me to solve for x. So that means I need to get x alone. And we do that using railroad tracks, right? You've been doing this for a long time. We want to get everything moved away from the x. But we might have to, and x is right here on the bottom, kind of stuck to that 2. It's on the bottom of a fraction. So it's really dug deep into the middle of this equation. And the way that we start this one is, remember when you have a fraction, the top is kind of like its own group, and the bottom is also kind of like its own group. It's like it is in parentheses. So that 2x minus r is a group. It's inside parentheses, but it's stuck on the bottom of a fraction. So the first thing we're going to do is get it out of the bottom. And I do that by the opposite of taking k and dividing by that entire bottom is to multiply by that entire bottom piece. So I'm going to multiply the right by 2x minus r, which is going to cancel it out. So that means I also have to multiply the left-hand side by 2x minus r. Now, when I do this, I'm going to actually write it like this. H times 2x minus r equals k. I'm not going to distribute that h yet because I'm trying to get x alone. And if I distribute that h, I'm adding more stuff to my x, and I'm trying to get rid of things. So instead, I have h multiplied by 2x minus r inside those parentheses. Well, I can't do anything on the inside of the parentheses till that h is gone. So I'm just going to divide by h on both sides. So now I just have 2x minus r left over, and that equals k over h. And now I want to get rid of the r. So I'm going to add r to the left. I'm going to add r to the right. And I'm going to rewrite this 2x equals k over h plus r. Now, something that I need you to be careful of. A capital H is not the same thing as a lowercase h when we're dealing with variables. So you cannot interchange them. If it gives you a capital H, you need to use a capital H throughout the entire problem. I know it seems like it's the same thing. It's not. Capital H represents something specifically, not the letter H, the capital letter H. So make sure that you keep writing them the way that they were given to you in the problem. Now the last thing I need to do is get rid of this 2. And the way that I do that is I divide both sides by 2. So x is going to equal, now when I divide k over h plus r all divided by 2, one of my options, I can actually just leave it written like that. I can have k over h, big H, plus r all divided by 2. A lot of times we don't like fractions inside fractions. So the other thing that you can do is you can divide those separately by 2. So you could write this as k over 2h plus r over 2. And that's what equals x. So x equals k over 2h plus r over 2. And I'm okay with you leaving it written this way. In fact, on a quiz, you might get partial credit for that one. But if you can simplify it, we like to, all right? Okay, number 2, solve for b sub 1. So we're going to call this b1. So we're trying to get this little b all by itself. Lot to get rid of. Let's see. I'm going to actually do this one in red so we don't mix it up with number 1. First thing I need to get rid of is the stuff on the outside of the parentheses. So the opposite of timesing by h is to divide by h. So I've got big A divided by h equals 1/2 b1 plus b2. Now I've got to get rid of that 1/2. And if you go back to 7th grade and 8th grade and 9th grade, there's two ways that I can do that. Okay, 1/2 is being multiplied. So I can either divide by 1/2 or I can multiply by we called it the reciprocal. You flip it over and you multiply, and that also gets rid of a fraction. It doesn't matter which way I do it. I prefer this one most of the time because it makes the math nicer. Otherwise, if you look at that left-hand side, if I were to divide by 1/2, I would have A divided by H divided by 1 divided by 2. So I've got a fraction on a fraction. That's ugly, that's messy. So instead, remember that you can multiply by the reciprocal. So I'm going to multiply by 2 over 1 on both sides. So A gets multiplied by 2, H gets multiplied by 1, and I'm just left with B1 plus B2 on the right-hand side. And now to get rid of the B2, I just minus B2. So B sub 1 is equal to 2 big A divided by H minus B sub 2. All right, maybe some tricks, some things you guys haven't seen for a while. Number 3, solve for pi. All right, so I need to get pi by itself, but there's more than one pi. And I can't add these together because one of them has an H and one of them has an R squared. So instead of trying to add these together, the trick that we do when there's more than one pi and things don't go together is we factor it out. So I'm going to rewrite this as S equals pi. I'm going to pull that out, and I'm left with 2r squared plus 2rh. Now getting pi by itself is really easy. All I have to do is divide by that giant parenthesis, 2r squared plus 2rh on both sides. So I end up with S divided by 2r squared plus 2rh, and that's going to equal pi. Please don't just write pi equals 3.14. I had someone do that last year. It wants it written with the variables that are in the problem. It doesn't want to know just what pi itself is, although that was a pretty clever answer. Okay, number 4, solve for D. Well, I feel like we just went backwards a step. We just got a lot easier. D is on the bottom. Well, I need to move it to the top. So I'm going to multiply both sides by D. So this becomes R times D equals K. And now I need to get rid of the R because I want D by itself. So I'm going to divide by R, divide by R. So D equals K over R. All right, number 5, solve for A. Big Q equals 1 over A plus 1 over B. So I'm trying to get this A by itself. And right now it's on the bottom of a fraction. We don't like that. But there's all these other things going on. So let's start moving away what we can. So when I do my railroad tracks, let's start by minusing 1 over B. Right? 1 over B is just a fraction. I can subtract that. So Q minus 1 over B equals 1 over A. All right, A's on the bottom. So to get it off the bottom, I have to multiply both sides by A. So I'm going to multiply both sides. On the left, I end up with A, and then in parentheses, I have Q minus 1 over B. And that's going to equal 1. Now, I'm not going to distribute the A because I'm trying to get things moved away from A, not add stuff to it. So I'm going to get rid of that parenthesis. So right now it's written like this. A times Q, whoops, that's a minus 1 over B equals 1. I want to divide both sides by that entire parenthesis. Because right now I'm multiplying by that entire parenthesis, so let's divide by it. So A, don't zoom out. What are we doing? A equals 1 divided by Q minus 1 over B. So that's one version of the answer. That right there is probably going to get you most of the points. It might even get you all the points. But typically, they don't like having b's, or they don't like having fractions in fractions. And the trick to get rid of this one, right now I have b on the bottom of a fraction in the bottom of a fraction. So if I were to, on this right-hand side, if I were to multiply the top by b and the bottom by b, technically I'm just multiplying by 1, so I'm not changing my answer. I'm just multiplying it by 1. But what that does is a becomes 1 times b on the top gives me b. And when I multiply the bottom by b, I've got to distribute it to everything. So I end up with a big Q times b. And here's what the trick gets rid of. That negative 1 over b, when I times by b, that becomes negative 1b over b. So those cancel. And I just end up with QB minus 1 on the bottom. It's the exact same answer. Now I just don't have a fraction inside another fraction. We use that in calculus all the time. In my calculus class to simplify expressions and equations because it's not fun doing math when you have fractions inside other fractions. It creates a lot of extra work. So number 6, solve for x. So I'm trying to get x by itself, and right now it's right here stuck inside a parenthesis. So we're going to use railroad tracks and start moving everything away. So the first thing I have to do is minus k. So y minus k equals a times x minus h squared. Well, x is still stuck on the inside. It's still right here. So let's divide by a. Divide by a, divide by a. So I get y minus k all divided by a equals x minus h squared. So x is still stuck on the inside. And the way I get rid of that is by square rooting, because I have a square on the outside. The opposite is to square root the left and the right. So on the left, I get the square root of y minus k divided by a, and that's going to equal, now my square is gone, so I just have x minus h. And we learned in the last chapter that we can actually treat this as 2 answers. In story problems, we don't usually use them both, but we know that when we square root something, we get 2 answers, right? So I'm going to move this up. Let's rewrite this. Plus minus square root y minus k divided by a equals x minus h. So x is almost alone. All I have to do is add h to both sides. So I get positive negative square root y minus k divided by a plus h equals x. And that's a good answer, just like it is. I have a fraction inside a square root, which is ugly and messy, but I can't do anything to simplify it, so I'm going to leave it right where it is. All right, number 7. This time, instead of getting rid of a square, we've got to get rid of this square root right here, right? But I'm trying to get a alone. Oh, I do also have to get rid of a square. Look at that. So railroad tracks. Be careful, because when this square root, remember the inside of this is a group. And I can't do anything on the inside until that square root goes away. So the opposite of a square root is a square. So if I square root the right, I have to square root the left. So I end up with c squared equals a squared plus b squared. Well, I want a alone. It's not there yet. So let's minus b squared from the right, minus b squared on the left. So c squared minus b squared equals a squared. And now to get a alone, I'm going to square root both sides. So I get a positive negative square root. C squared minus b squared equals a. And that's my final answer. Nothing simplifies further than that. Okay, number 8. Solve for b. Okay, so I have a b over here. I also have a b on the right. So I need to get, well, first of all, those b's need to be on the same side. I can't do anything when they're on opposite sides. So let's go ahead and minus this 2BC, I'm going to minus it from both sides. So I get 3AB minus 2BC equals negative AC that's still left over there. Now, again, I've got a B in two different terms. And the terms I can't add those together because one of them has an A, one of them has a C. So I'm going to do my factoring trick where instead of putting those together, I'm going to factor the B out. So I'm left with 3A minus 2C, and that's going to equal negative AC. Now to get B alone, I'm just going to divide by that entire parenthesis. Divide by 3A minus 2C. So divide by 3A minus 2C. So big B equals negative AC divided by 3A minus 2C. Depending on how you moved things around, you could have also ended up with B equals positive AC divided by 2C minus 3A. Both of these they're the exact same answer. They're just written two different ways. One, the negative's on the top. The other one, the negative's down on the bottom. But the answers are exactly the same.